Today is a two-part video. The first part is defining positives and negatives in kinematic equations. And it's going to help us kind of determine when we should be using a positive symbol or a negative symbol and how that kind of works in these equations. The second part I'm actually going to do first is with implicit unknowns. Right, so with implicit unknowns. So there might be unknowns that come up and you can actually define them based on the vocabulary in the problem. For example, let's look at this problem given here. And it says a car with an initial velocity of 20 meters per second comes to a rest after 4 seconds. And comes to a rest should actually tell us something in this problem even before we go into it. Like, let's say we're making our little known and unknown chart here. We say, well, what are the things I know here? I know my initial velocity is 20 meters per second because they told us that. We know our time is 4 seconds. Again, they told us that. We're trying to find our acceleration. But there's one more thing that we know here, even though it was not directly stated. The thing we know here, even though it was not directly stated, is based on this phrase, comes to a rest. And if you ever see comes to a rest, you know that final velocity is 0 meters per second. There are other implied unknowns here as well. If an object is at rest, if an object starts at rest, it has an initial velocity of 0 meters per second. If an object has a constant velocity, its acceleration is 0 meters per second. Because acceleration is the rate of change of velocity. So if you have no change to velocity, you have no acceleration at all. So this would be the rate of change of velocity. So constant velocity means acceleration is 0. So these are 3 phrases, and there's going to be a couple more of these that you know mathematical values based on vocabulary used. At rest, initial velocity is 0. Comes to a rest, final velocity is 0. Constant velocity, acceleration is 0. That brings us into this problem. Well, initial velocity is 20, time is 4, final velocity is 0, acceleration is unknown. We can use our implied unknown final velocity to set up an equation. Which equation here uses initial velocity, time, final velocity, and acceleration? We're going to use Vf squared equals Vi squared plus 2a. Oh, no, we're not. Ooh, that was close. We're going to use Vf equals Vi plus At. I meant to write a different problem here, but there we go. Vf equals Vi plus At is our equation. So final velocity equals initial velocity plus acceleration times time. Let's look what happened when we substitute. I also want to remind everybody, please substitute with units. They're going to grade for that on the region exam. So notice how I wrote the equation. Now I'm substituting with units. You must always substitute with units. You can solve without units, but you must substitute with units, and your final answer must have units. Let's watch what happens here. Subtract 20 to the other side. Negative 20 meters per second equals 4 seconds times a. You divide by 4 seconds, and you get an acceleration of negative 20 over 4, negative 5 meters per second squared. Negative 5 meters per second squared. That negative should be very interesting to us. That negative sign is going to tell us some properties about this problem. First of all, is this car slowing down or speeding up? Well, if we take a look, it started with a velocity of 20 and came to a rest. So this object is slowing down. What happened here? The problem defined the forward direction as positive. It defined the direction the car was going in as positive, positive 20 meters per second. Which means the direction the car was moving away from would be defined as negative. However, because the car was slowing down, the acceleration must have been pulling in the opposite direction, slowing it down at 5 meters per second squared. So we had an acceleration of negative 5 meters per second squared. This shows the direction of the acceleration. I've showed the acceleration in blue, the positive velocity in black. What does that mean for us? Well, these frames, these positives and negatives, are defined in every problem. If they state positive 20 meters per second, that means that direction is positive. If they state a ball is, let's say, thrown upwards, if you say an object is thrown upwards at 10 meters per second, positive 10 meters per second, well, then you just defined upwards as positive. So what does that mean about downwards? Well, downwards would therefore be negative. And anything in the negative direction would have to have a negative sign in front of it. Anything downwards here would have to have a negative sign in front of it. For example, I'll give you an easy one. Gravity is going to be downwards, and we're going to make that negative in its signs. Here it happens to be negative 9.8 meters per second squared, but we'll talk about that more soon. So let's talk about the real implications of this. You're going to define positive and negative in these scenarios. Let's talk about the 4 possible outcomes. Let's talk first. If velocity is positive and acceleration is positive, what is the object doing? If acceleration is positive and velocity is positive, the object is speeding up in the positive direction. It's getting faster and faster. It has positive acceleration. It is going to speed up in the positive direction. So the velocity would grow and grow as time goes on because the acceleration is positive. What if you had a positive velocity but a negative acceleration? Well, this object would be slowing down because it has a positive velocity and negative acceleration. This is going to lower that velocity. If you made a chart here, the velocity starts at 20, then 15, then 10, then 5, and then 0 when it comes to a rest. So negative acceleration, positive velocity, it is slowing down. Now let's talk about the other scenario. What if you had a velocity in the negative direction, an object moving towards the negative side? Well, let's say we had a negative velocity and a negative acceleration. This is speeding up, but now it's speeding up in the negative direction. So it could be moving backwards, or it could be moving downwards, but getting faster and faster. And if we had a negative velocity, so it's moving backwards, but a positive acceleration pulling it forwards, well, then it would be slowing down while moving backwards. So this would be slowing down while still moving in the negative direction. You might also notice that when acceleration and velocity have opposite signs, when they have opposite signs, the object slows down. When they have the same signs, the object speeds up. Just as a recap, these positive and negatives often defined by the problem, by whatever positive value they give you in the problem. You might draw out a little diagram and see what's positive, what's negative, what's up, what's down. You define those, but make sure you're careful with them, and then use those signs in your equation. Like if you had this negative 5 meters per second squared and you needed another problem, make sure you use the correct sign in your equation because it's going to affect your outcome. And that's why when we talk about vectors, it's so important to keep in mind that velocity, acceleration, displacement are vectors. Direction matters because the direction is going to tell you if it's positive or negative, amongst other things. That's it for defining positive and negatives with implicit unknowns.